right, yesterday we talked about discovering the function rule with the patterns.
Yeah.
So I want to know, what is your function rule?
Our function rule is y equals 2x plus 3.
2x plus 3. Now, so how did you discover it?
Okay, so we looked at the numbers and we looked at the dots and we figured out that the dots.
Hey everybody, I'm recording now. If you can keep your voices down just a little bit so they can pick up. Yes.
Figured out that the dots were the y and the numbers were the x because the number of dots depended on the number.
Okay.
And so Lizzie was playing around or whatever and figured out that 1 times 2 equals 2, and then you add 3, you get 5, and then she did it with the rest of the numbers. So, yeah.
You say who figured that out? Okay, good. So what's the pattern? So how do I see the function rule within the dots? Which is, your function rule again is what?
2x plus 3.
2x plus 3. So how do I see that continually within the dots?
Well, we chose 3 to be 3 in each row because it's the constant in the equation, and that's the way it was presented to us.
So where's the 3 in each dot?
Well, you can see the numbers here, and you can take the bottom two right here, and these, and these, and you can see that the 3 that were added onto each. Right. That.
Okay, so this is what I want y'all to work on. If you're saying that 3 is the constant, it should be constant throughout the pattern. So where could I see the constant 3 throughout the pattern and then represented the 2x? So think about that. Where do I see a constant 3? On the bottom row. And so where will be the 2x be represented at? Okay, use one. Use this for example.
Okay, so 3 times 2 is right first, that's 6, and then you add the 3.
Okay, do that for the next one.
4 times 2 is 8, and then you change it to 5, 6, 7, 8, and then you add 3.
Pick up just a little bit.
Okay, so 4 times 2 gives you 8, so that's 1, 2, 3, 4, 5, 6, 7, 8, and then you add the 3, which is the bottom right.
Okay, so now when we go negative, because it asks you to give us the function rule from negative 3 to 6, why do your dots look like this in the negative?
Because it would represent that there's nothing there. It represents that there's value, like numbers away from 0, but it's set to be negative because there's nothing there.
So your positive dots are
Good.
okay. So is there any other patterns that you see in the dots? Why did you place them the way you placed them? So you have this here, this here, this here. Why are they placed the way they're placed? Because that's important too. And that's what I did when I created it. Okay, so think about that because you need to tell me that. All right, let's keep it moving. Okay, ladies. So your function rule is what? 1/2 x plus 3. So how do I see the function rule? Well, let me ask you that. So you're basically saying half of x and then add 3 onto it. So which one is your x and which one is your y with the dots?
Our number is the x,
Okay.
and the dots are the y.
So half of 2 is,
1,
and then plus 3 is,
4,
okay. Half of 4 is,
2,
and then plus 3 is,
5,
okay. Half of 6 is,
3,
and then plus 3 is,
6.
okay. So it seems like it's working. All right, so in your function rule, where do I see the function rule within the problem?
The numbers are the dots.
Between with the dots. Because if this is the function rule, how is the function rule represented in the dots? How is half of x plus 3 represented in the dots? Because in your presentation, be able to explain how the function rule relates to the picture. Very big part of this lesson. So you need to look in these dots and see, where do I see my constant And where do I see my coefficient multiplied by my input to give me my output? Because that is the major meat of this lesson. Okay, so this is, what's this graph of? The table? Okay, so what type of function is this? Is it quadratic, linear, cubic? Linear. So what's the issue y'all are having right here? Cassandra, what does linear mean?
It's a line.
Okay, so something needs to happen here, right? Okay, y'all need to figure that out because this is not a straight line.
Wait, so would that be a different type of function, or like we just did that wrong?
Well, if this is linear, it should make what kind of line, Samira? A diagonal line or a straight line. So if your graph is not making a diagonal line and the equation is linear, then figure out what's going on here.
I mean, it is like a diagonal line if we don't connect these two.
So let me show you this. This is linear. This is linear. This is linear. This is linear. This is not linear because it's a straight line. There is a constant rate of change. This is not change, it's not constant. And it changes here, it changes here. So this equation, according to what we learned, should have a what type of change? Constant rate of change. So figure out what you did wrong. All right, moving on. I have the big level 4 problem.
Yeah.
So, what is the function rule?
X minus 1. This is the square root of x. The square root of x minus 1.
Okay, so that's the function rule. So y equals the square root of x minus 1 should be the entire function rule. So I am interested in seeing who came up with what, or what was the... Okay, I see 2 hands, so... Okay.
Yeah. We both kind of figured it was like team and team.
When they're talking.
We had little revelations at almost the exact same time.
Yeah.
Yeah, I did it backwards
Okay.
several times.
And then,
So I want to talk about the backwards. So what were you doing backwards?
well, we saw it 37, 20. Yeah, 37. It was in 26. I saw that they were one away from like 25 and 36, which I knew could be square. Like could have like a square root.
Okay.
And so then, once we saw that this could also, one away would be 9 and then one away would be 16, we saw that it would also have the same square root.
So you saw that this number, correct me if I'm wrong, this number squared was giving you 36 and then you would plus 1. But because that's working backwards, you said what?
That 37 minus 1 would be 36, then to the square root.
Okay. Okay, impressive. All right, so in your presentation is asking you to represent what the graph of the domains of 1, 5, 10, 17, 26, and 37. Y'all have that represented? Okay, and then it asks you to, I want you to tell me, where is it at? Draw what f of 0, f of 1, f of 5 will look like. Have y'all gotten to that part yet? Okay. So if these dots are continued, what would f of 0 look like? Okay, why not?
Because you can't have it.
Let me hear from Camille. So why would f of 0, they said it's no solution, it can't be determined. Why is that the case?
Well, because I'll only be 0 right there, meaning there'll be really no point in mine. I should just want to put it on.
Speak up just a little bit, we want the camera to hear you.
So since it's 0, there will be no real point to putting it because it'll just be on the 0 axis.
says this X right here.
Okay, Hippin has something else to say. Let's move back here.
So
Don't fall guys.
in f of 0, since our function rule is the square root of x minus 1, so 0 minus 1 is negative 1. But there, you can't have a square root of a negative number because a number squared is itself times itself. And if one of those itself is negative and one of those is positive, it's not a real square root. So you can't have the square root of a negative number.
So, how would y'all represent that when I asked you, when you get the big paper and you have to spread these dots out and recreate that, how would you represent f of 0? How would you represent it on the graph? Or as dots? Is that something I need to leave with y'all to think about?
So I would say leave the dots open instead of shading and showing that they represent nothing.
Oh yeah.
Oh, well, see, I thought the same thing. It's not going to have the negative number.
So y'all need to figure out, because at 1, what's the answer?
It's 0, so
Okay.
it's nothing. Oh yeah, we could leave it open because then it's like the opposite of that. And it shows it's
Well, what's the opposite of these? Sorry.
It would be unshaded.
It'd be the opposite of these. It's negative 2.
So is negative 2 the opposite of something that can't happen? Because y'all trying to tell me to do the opposite of these dots. If I do the opposite of these dots represent what? What type of numbers? Real, but more importantly, what type of real numbers? Look at your chart. Positive. So the opposite of positive would be negative. So if you can't,
You can put this.
Oh, why you're drawing?
so I'm gonna leave y'all because I gotta go to another group. But think about this. If 0 is represented by nothing there, the opposite of this would be a negative number. Y'all need to be creative mathematically and think about what would something impossible be represented as. I'm moving on. I'll be back. Yeah.
I like to feel like
Negative
See, she did like
we have to check our words before we can get
Good. Let's come up and talk. Okay, what's up? Okay, let me see the dots. Yeah. All right, so your function rule is 5x minus 2. Now, who found the function rule? Okay, how did you find it?
I was just plugging in different numbers, and then where's the sheet? So it started off like this, and then I would multiply by 2, and then try it, and it didn't work. And then I tried 3, and then 4, and then 5, and then it worked. So I kept on plugging numbers in.
Okay, and so you finally said that y equals 5x minus 2. Or f of x. Okay, so where can I see the function rule within the dots?
Well, you can see that there are 8 dots. But you can see that there are 8 dots.
Okay.
So you would do 2 times 5, and then that minus 2. And 2 times 5 is 10, and 10 minus 2 is 8. So that matches. And same for 3, because there are 13 dots, and if you do 3 times 5, 13, and then minus 2, then that's 13.
Okay, that's good. But y'all have level 1.5, right?
Yeah.
Okay, so in level 1.5, you need to be able to explain to me how do I specifically see 5 times x minus 2 in every picture. Not that there are 13 dots, not that there are 5 times 2 is 10, but minus.
I see it now.
Okay, so that's what you need to explain. Hold on, give him a chance because you did a lot of talking. I want to hear from somebody else real quick.
Do you see it?
Yeah, because 1, 2, 3, 4, 5. That's like a pattern right there.
Okay.
Then you would do the x, and there's 2 dots on it.
Okay, so the function rule again. What's your function rule again?
5x minus 2.
So 5x minus 2 should show me the 5 times the x.
It would usually be like if it was just 5x, there would be 2 dots right here.
Okay.
Since it's 5x minus 2, there's no 2 dots right there.
Good, good, good. Because that's a big part of your presentation.